All right, today we're breaking down two absolute powerhouses of the digital world, supercomputers and data centers. Now, you've probably heard of both, and you know they both crunch just incredible amounts of data. But the thing is, they do it in fundamentally different ways for completely different reasons. So let's just dive right in. The whole difference between these two giants really boils down to one simple question. Are you trying to solve one single monumental problem, like, say, simulating the collision of two galaxies, or are you trying to solve millions of tiny problems all at once, like serving up search results to everyone on the planet at the exact same time? To really wrap your head around these two titans, you've got to understand that they were built from the ground up for two totally different kinds of challenges. It really all comes down to the nature of the problem you're trying to solve. Okay, here's probably the best way to picture this. Think of a supercomputer as a Formula One car. It's this beautiful, exquisitely engineered machine built for one thing and one thing only: pure, focused, blistering speed on a single task. A data center, on the other hand, that's more like a massive fleet of delivery vans. No single van's going to break any speed records, but altogether, they can deliver an unbelievable volume of packages all across the city all at the same time. Now, before we really put these two head-to-head, we need to get on the same page with a couple of key terms. Honestly, this is the language of high-performance computing, and once you get these two ideas, everything else just clicks into place. First up is latency. All this means is how long it takes to do one single thing. Let's go back to our F1 car. Latency is the lap time. How long does it take to complete one perfect lightning-fast lap? And in computing, it's how fast you can get a single calculation done. For supercomputers, getting that latency as low as humanly possible is everything. It's the holy grail. And on the complete flip side, you have throughput. Here, we don't care about the speed of one van. What we care about is the total number of packages the entire fleet can deliver in a day. It's all about the total amount of work you can get done over time. And for data centers, which are juggling millions of user requests, maximizing throughput is the name of the game. All right, so now we've got the lingo down, right? Latency versus throughput. The F1 car versus the delivery fleet. So let's put these two systems side by side and really dig into what makes them tick. Now, the source material gives us this great table that lays out all the core differences. Don't worry about squinting to read every single word here. Just think of this as our roadmap for the next few minutes. We're going to walk through the most important pieces one by one. First up, what are these things actually for? Supercomputers are specialists. They're built for a very small number of absolutely massive customized jobs. We're talking complex scientific modeling, nuclear simulations, that kind of thing. Data centers are the polar opposite. They are built to handle a constant blizzard of small, everyday tasks like loading a web page or streaming a video for millions of us all at once. And you know, that difference in purpose leads to a totally different philosophy when it comes to hardware. A supercomputer is all about expensive, custom-built parts with incredibly fast, low-latency connections between them. Why? Because for that one giant calculation, every part needs to talk to every other part instantly. A data center, though, is built with cheaper, off-the-shelf components. The goal is to keep costs low and optimize for throughput. It's okay if one connection is a little slow because you have thousands of others working in parallel. So then, how do you manage them? Well, a supercomputer's job is all planned out in advance. It's called static scheduling. You load up the massive job, hit go, and the system just executes it with as little interference as possible. A data center has to be way more flexible. It uses what's called dynamic allocation, which is basically a fancy way of saying it's assigning resources on the fly, as millions of unpredictable user requests come pouring in from all over the world. And this kind of brings us to the final brilliant difference. Who's in control? When you're programming a supercomputer, you are in control. You're a master craftsman, managing the hardware directly at a very low level. With a data center, you're operating at a much higher level. You basically just tell the system what you want done with the data, and the system itself automatically figures out how to manage all the resources to make it happen. But, and this is where the story gets really interesting, it doesn't just end there, because even though these systems were designed with opposite goals in mind, the lines between them are starting to get seriously blurry. What we're seeing is something people are calling the Great Convergence. So on one hand, you have data centers, traditionally built for volume, getting packed with super powerful GPUs. This lets them tackle huge singular problems, like training the large AI models that power things like language translation, stuff that used to be only for supercomputers. And at the exact same time, supercomputers are borrowing tricks from data centers to become more flexible and fault-tolerant, so they can handle more than just one giant task at a time.
So after looking at how different they are, their core purpose, and now how they're starting to overlap, what does this all mean for the future of computing?
At the end of the day, it's really not a competition. It's not about which one is better. You wouldn't use an F1 car to deliver pizzas, right? And you wouldn't enter a fleet of delivery vans in a Grand Prix. It's all about understanding the nature of the problem you're trying to solve and then picking the highly specialized tool that was built for that exact challenge. And that leaves us with this one big, fascinating question for the future. As the problems we face get more and more complex, I'm talking about everything from climate modeling to artificial intelligence, will one of these approaches eventually just win? Or are we actually watching the birth of a totally new hybrid titan that combines the raw speed of that F1 car with the massive scale of the delivery fleet? The answer to that is probably going to define the next era of technology.